Hi, it's Gadget UK here again, back for the second part of the MV4 repair here. In the first video we swapped out the SRAM there. It took a little bit of work to work out that was the actual fault, but if you've not seen that video, yeah, check out part one. In this video it's mostly clean-up work actually. You know, I'll be open and honest right from the start here. You know, if you've seen a lot of my videos before, there's probably not going to be a massive amount to see in this video. You might want to skip some of the PCB cleaning stuff. Although I kind of developed a nice technique there for cleaning up the rust marks on the PCB there from the screw mounts and stuff. And later in this video we cover some electrolysis there, removing the rust with electrolysis and then zinc plating it. So sorry it's going dark and it's raining. There's a couple of pins here that just need straightening ever so slightly, so, and you can see I've been cleaning these up just with a bit of lightly abrasive sandpaper. I mean, look how bad the one is here, they were all like that. I've got it underneath the connectors as well, you know, try and clean the underside. But bear in mind, you know, there's only so much cleaning you can do on things like this. You could replace the connectors. You could use deoxit or something like that, that might do a better job. But you can see those have come out pretty good actually. And the pins are nice and straight there now. Well, pretty straight, they're not perfect. I mean, they're quite sturdy, so they're resilient, those, to having a little bit of a bend. So after doing all the work to clean up the bottom board, I just tested it and it's working fine. I did find that the slots needed cleaning again, and it's because, like I say, it's not been used in a while, a week or two, and they're very dirty. I think they need more work, so I've ordered some deoxit actually. It's super expensive. I wanted to get the spray type, and it's like £25 a tin or something, so I just couldn't afford it. I thought it's just no point in spending that amount. So what I've done is ordered like a 2cc tube of the stuff, and I can just use it sparingly just to, you know, clean the contacts. But you can see how dirty this is. There's just a bit of corrosion there at the edge where the support pillars and screws and things, and the bit, you know, the top, the shell on top has leaked rust on there. It's awful, absolutely awful this. I've got a chemical rust remover. I might have a go just in a patch with that first of all. I'll show you that in a minute, and we'll just leave it you know, for a few hours or overnight or something, and just see how effective or efficient that is. If it's good, I might use it on the whole thing and then finally go over it with some sandpaper or something at the end, just to get any final bits of rust off. I might not even need to use the sandpaper, it depends how effective the chemical stuff is. So to start with, I've put some of this rust removing jelly on there, and we'll just leave it. We'll just see what difference that makes. If it ends up being any good, I'll order some more of it and I'll do the rest using that. Well, you wouldn't believe it, it's taken 20 minutes just to do this centre part of the board, and can you see the contrast? We're getting the right light. There's a huge, huge difference. Yeah, I tried to use the fiberglass pen a little bit here, but it's just not coming off. You can see how bumpy and horrible that is there. So again, I'll get some vinegar on there and just leave that soaking for a bit. Something else worth showing you here. You can have more success dry cleaning these than wet cleaning them. So, for example, you know, the bit down here I went over with IPA first of all, and then a dry cotton bud, and then after it dries you get horrible streaks all over the place. Then you go over it with another dry cotton bud. But if we just use a dry cotton bud, just watch this, can you see this bit here? It looks awful, and I find that you've got to go different directions. You have to go this way because the traces run that way, and you get the dirt from in between the traces, whereas if you go, and you can see that's brought that off there, if I go that way it doesn't always get it off between the gaps. You get lines down in between the traces. It's amazing how the dirt adheres in between the traces there, but can you see that? I know it's a bit over bright in here, and you can see how clean that area is that I've just gone over there. Now I'll probably go over that again with IPA afterwards and then a dry cotton bud, just to make sure it's super clean. But I just wanted to show you that, you know, that you can literally just use dry cotton buds sometimes with these. Depends on the type of dirt that's on there. And the more I go around this while I'm cleaning, the more amazed I am that this is even working at all. Can you see here? The trace, look, it's hardly visible at all. It's like there's two traces there, and the one here is corroded and a bit of exposed copper. So these are the things you only see when you start to clean up, you know, and that's going to need some remedial fix or something. I'll probably just scrape off, might be able to do it with this tool here, the stuff that's on the top there, get some flux on and tin it up, and if it needs it, maybe patch it with a wire link or something underneath. But you can see that's a state, it really is. So as I go around this, any areas like that I've cleaned up, and I've just scratched off the surface, you can't really see from this distance, I'm just marking it up so that when I finish cleaning this up, I know that I need to revisit here and do something with that just to protect it, check it. You know, it could be a source of failure. It could also, you know, cleaning this up, it could also generate faults. I may find after I clean this up now, come to test it, some slots don't work or it just doesn't work at all. And that's another reason, so just as a reminder, actually, let's just revisit that area there, just make sure I didn't disturb it further, because, you know, there was some copper exposed there already, and the trace had all sort of bubbled up and gone horrible. So, you know, that could have been on its very last legs, and me cleaning it could have broken the connectivity there. So anyway, it's just a reminder. Can you see there's like an orange sort of tinge to these chips here, and then as soon as you get down here, these ones I've cleaned up a little bit. And look at the colour. It's like a reddy sort of orangey, pinky colour that's coming off these. It's the rust from the top side, you know, you can see it a bit more there, it's a bit more evident there. It's a miracle that this actually works. I'm amazed that this has been so resilient, this top board, despite all the corrosion that's got on top of it. So I'm finally getting near the end of cleaning this. It's been a majority of the work actually. I've probably spent 5 times more cleaning this than the actual repair. So you can see I'm just in this area here now, and can you see how browny red that is? If I just get you a bit closer, it's an awful, you know, it looks dull, and it's super hard to clean. You know, what I'm going to do here is use the cotton butter to clean all around the edges, and then the toothbrush to go over it, but you'll still find it looks red because of the rust. And if you compare to the side I did over here, look at that side, that looks almost like new. And all I did there is after I finished cleaning around and using the toothbrush and stuff, it goes all red, and you know, you don't get the dirt from in between the gaps there. So then use the fiberglass pen just lightly, just a few passes, and then brush it off with the toothbrush, and it looks like new. You get all that contamination off the surface there with the fiberglass pen. So there you go. After cleaning around it, you can see, you know, around here it does look super clean, but it looks really red still. And I'll just show you, even with a toothbrush here, even after I've gone over this with a toothbrush a number of times and let it dry, it will still look red. It does not bring off this at all, which is why I will go over it with the fiberglass pen. So I think, to be fair, it has removed some of the contaminants there, but I don't think you can see, they just look really oxidised and awful actually, and I just don't want to take any chances with connectivity going bad. So it's difficult to know what to do with these corner bits here, because they've been cleaned, can you see, but it's corrosion again from the top shell that's just sat there, and it's sort of eaten its way into the top of the PCB. I've tried a few things on this actually. I also tried some of this, because, you know, that Plastex was cleaning up super well, until I realised when I zoomed in super close, you could still see like metal deposits, you know, from the rust on top, because it's not actually the metal of the PCB that's rusted, it's metal from the top of the shell that's landed on the board. So I tried some chemical rust remover. That didn't really work very well, if I'm honest, because you've got to leave it on for a long period of time. But the easy way, I mean, I've just scratched, can you see it looks a bit reddy there? If I just zoom you in a little bit, can you see it's looking a bit red? There's little bits of metal, and, you know, I've managed to just scratch them off there, but I'm going to use the wire brush actually, just on these bits here, because there's no connections or anything there. It's just where, let's say, the metal has corroded from the top and landed on here and sort of eaten its way into the top. Made a bit of a nest there, effectively. I'll try and show you what I mean, because someone's bound to say, you know, why aren't you just using a fiberglass brush? It's less abrasive. Can you see? Let me just bring the tool in here. It's metal. You've got metal that's come off the shell. Let's see if I can just move this. Hang on a sec. It's hard to keep the camera stable at the same time. Can you see that? Yeah, it's like metal that's kind of disintegrated and eaten its way into the surface. it will come off with, let's say, some friction like that on the brush. It's not the metal of the PCB, you know, it's just surface contaminant effectively. So there we go, hopefully you can see the difference. I've cleaned it with the plastic. Can you see the black and greeny marks that have come off there? That looks pretty much good as new now. So yeah, I'll do the same thing on the others. I need to use, let's say, this to scratch some of the corrosion, wire brush, and then clean with plastics at the end. And you can get all of the contaminants from around there. But I tell you what, the rusted metal that was on top of there is really well sort of, what's the word? You know, it's well eaten into the PCB. It's super hard to get it off. I'll just quickly show you the other points. Can you see here? There's a lot of it down here, and then over here again. That one's particularly bad there. And this corner's perhaps the worst. I don't know if you can see that. Yeah, so I'm having to use this tool to start with because the wire brush will not get it off. Actually, I probably would have put a lot of force on, but I've been scratching off initially with this, and then using the wire brush, and then use the plastics. So the next thing I'm going to do here is, as you can see, I've got some deoxit, the smallest tube in the world, I think. It was like £7. It's ridiculously expensive in the UK. This, I suspect it's not as much if you're in the States, because that's where it's manufactured. But I'm going to get the smallest amount onto this actually, and clean up the slots, in particular slot 1, because I found that even though it's been cleaned and cleaned and cleaned, I mean, I haven't vacuumed it yet. I'll do that as well. It's not very reliable. Slot 1. You've got to get the car in at just the right angle. Otherwise, it plays up. You know, you can actually move the car. I might be able to show you that if it's still doing it after this. But I figure, why not give these slots some of the deoxit treatment here. It's not too thick, this, it's just the right thickness, you know. If I twist it at an angle, I can get some friction on either side of the connections there. But I mean, can you see that? You can see how black that is? It's been like that a number of times, despite the amount of times I've cleaned this. It's ridiculous how dirty these slots are. I'll clean with IPA again afterwards, actually, and some dry paper. So I've gone over all the slots there. Look how dirty those are. So the slots are super clean, but I'm just going to vacuum them out as well, just to make sure I don't get any particles and stuff and bits of paper or whatever from cleaning. So I think the boards are as clean as I want to get them for now, so I'll just give you a quick look. It's looking super shiny. All the corrosion marks and things have been cleaned off the tops of the connectors here. You know, well, it's just a soldered part, but still, the last thing you want is rust starting on one of those. It's looking super clean, so we'll go and give that a try now, I think. So I've got it connected up to the super gun, and we'll try it initially without any carts in. So we're using the original mask ROM. I think it says Rev 5. Yeah, so that's working. I'll switch it off, and I'll try slot 1, because slot 1 is has been the most problematic slot. You know, I didn't work on this for a few days, and I came to test it again, and slot 1 wasn't working at all. Got no sound there. Let's just try that again. It was a graphical thing I was getting with slot 1 mainly. Yeah, see, like that. So yeah, it was just a dirty slot. So let's try slot 2. I've got graphical problems now after cleaning up slot 2. Let's try slot 3. Yeah, slot 3's alright, so slot 2 just needs another clean, I think. Yeah, slot 4's alright. I'll just let that run through the eye catcher. Cleaned up slot 2, it just needed a second clean really with that deoxin, it's fine now. Got 4 carts in there, I'll just let that go through. I'll perhaps speed up some of this because you don't want to wait for every single demo to go through, but I just want to see if it cycles through the slots like it should. So you can see there on the underside where I tinned up a load of those exposed traces. It wasn't something I did, it was something that had been previously done to this. So I'm just going to cover that with a little bit of nail polish just in that area. So the other thing we need to do something with is this wire on the, it's the ground actually for the potentiometer for the volume, you know, for the master volume, for the speakers. So we'll remove that wire there, I'll just introduce some fresh solder and flux. That solder looks awful. You can probably just about see what I'm doing here, flicking solder on the carpet, look. This carpet needs replacing anyway, it's something I've been meaning to do for a while. Just heat up that side. That was incredibly hard to remove that one. And the reason being obviously is because this is going to be connected to the ground plane. I'm just going to remove some of that solder actually. It doesn't need anywhere near as much as was on there. I'll do the same on that side. Oh, that side's not too bad actually. Yeah, I'll just get the new wire on and we'll just clean that up with some IPA and a cotton bud. And you know, just thinking about this, I don't think I need a wire on there. I think someone's done a fudge fix to this. Maybe it's only outputting on one side or something. I'll tell you why. Because if I just test on continuity, let me just show you something. Bring the meter into so just testing on continuity, there is no join between those two there. These two are joined. And then I'm guessing these two are perhaps the left and right. They're going down to, they've got connections there. Yeah, that's right, it's those two there. So, I don't know, I'm going to try it without that. That's a bit crazy, that wire. And a quick look on the underside of this board. I mean, you can still see in a few places it's a little bit dirty. And there's a few marks around here where I've been cleaning. What I did, there was a bit of corrosion on the cap points here, and I reflowed all of these actually. It took an incredible amount of flux and heat to redo those, but as a result, you know, you can see the bit I've cleaned. If you get it in the light, you can see this bit's super shiny, and there's little dirty marks. You know, I could spend a lot of time cleaning that, but I just don't see the point. It looks pretty good as it is. Now, there's no damage or anything to the underside of that board. There was that one spot which I can't see, that's down here. Yeah, you'll remember when we were cleaning up we had a dark black corroded trace there, and I just scratched the surface of it, tinned it with some solder and flux, and then I've just put some green nail polish over that to protect that. I tested continuity, it goes up to one of the pins here, I forget which, it goes under the chip and then up to one of the pins here I think. And a quick look on the bottom board, you can see it is looking absolutely immaculate. It really is, you know, cleaned up the connector here as well. It's the nice gold plated ones on these. Don't use fiberglass brush or anything like that, just IPA and paper towel. I mean, there's the odd little mark on the board here, you know, that's probably where I've just touched it more than anything. But as you can see, it looks super, super, super clean. So the actual faults is surprising, you know, the fact that faulty, 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 all 6 SRAMs there, faulty. It's not something you typically see. Sometimes these things fail in pairs, like when the fast SRAM's over here, when one of those fails, more than often than not, the other one fails at the same time. Usually that's some sort of indicative of some sort of power issue. You get a spike or something on the 5-volt line there, one of these, and both of them usually go. But it is uncommon to see a whole bank of 6 of those all fail at exactly the same point in time. So what would have caused that? Well, the only thing they've got in common is the 5-volt rail, really. You know, because these sit on the different bus to these, so it's not like it's had an ESD charge, you know, static charge somewhere from handling that might have killed that RAM all at the same time via one of the data bus connections or something like that. It could have done from the 5-volt rail. Maybe someone's I don't know, done something to the 5-volt side on this. You know, touched the connector on the jammer edge there, and it's sent some ESD into the board, and for whatever reason all 6 of these are taking offence to it. It could just be end of life thing. You know, sometimes you do get batches where these things they only last so long, and maybe they all seem to die at the same time, but I find that hard to believe that they'd all die at precisely the same time. I mean, it could well be that this was in a cabinet somewhere, left running, it failed with, I don't know, let's say backup RAM faults, and someone just kept powering it on every day. It was just left sat there, you know, with a backup RAM error, so eventually the other chips died as well. I don't know, but you'd think that these would need to be in use for that sort of failure to happen, and I guess when you've got a backup RAM, it's going to just sit there doing nothing. But then again, if it's outputting an error, it's going to be hitting the word RAM. You know, if you had a backup RAM, it's going to be hitting the word RAM as it runs through its code, and it's outputting to the display. It's using the video RAM there. So yeah, it's feasible that, let's say, a fault occurred and it was left powered up for a prolonged period of time thereafter, which, you know, caused the other chips to eventually reach their end of life. I don't know. But as you can see, I did quite a good job on the soldering there. Other than the fact that you've got some different chips, you'd never know, you never know that perhaps that's been worked on. It is unfortunate that I got the wrong end of the stick to start with and started looking around stuff to do with the ROM address decoding. We ended up with one socketed there as well. One thing I did spot, and I've not shown you, I put a little fixed wire, I'll show you in a sec, a fixed wire underneath this 161, because at the point where I was trying to address the clocks, you know, trying to work my way through the clock circuitry to understand whether all the clocks were part of the problem. I mean, they weren't ultimately. It was just after that I went away and thought maybe all the SRAMs failed at the same time. It's funny how my mind works. But anyway, I was on the point where I was measuring the clocks, and I think my scope probe's got like a grounded ring around the end, and I was measuring the pins around here, and bang, the system went off, and I thought, that's strange, why have we now not got power? And I switched my ATX power supply off and on. It wouldn't come back on. And I thought, oh no, you know, have I killed the power supply here, or is the board shorting it out? And I went away for a few minutes, came back, switched the ATX power supply back on, and it was okay. I've had problems with that power supply like that before. I think when you get short, some sort of cut-off happens, and if you don't switch it off for a good 30 seconds, you can't switch it back on. But at that point, everything was okay. I then went over and looked back at the SRAM side of things, and I'm glad I did, because that was ultimately the cause. And I never thought anything else about it. But when I came to clean up a minute ago, underneath, I'll show you, I spotted a burnt-out trace. Now, there's a question in my mind as how on earth has this been running with a burnt-out trace? And it's going to be related to, well, it's obviously something that's not absolutely critical. There's a connection here on the underside of the 161, and it goes 1, 2, 3, 4 pins across. You can see the little wire there with a little bit of nail polish just securing it. That trace that went between those two is burnt out, and it was completely open circuit. So again, you know, you can see a bit of dirt and stuff around here, you know, there's some streaks over here. It's incredibly time consuming to clean these, but as things stand, I think you'll agree, it's pretty good actually. You can see the bit of nail polish there, because there were some exposed traces, not from something I'd done. There was like a patch there that was just, you know, I don't know, 6 or 7 traces that were all just copper. So yeah, a bit of nail polish there, and again, there were a few over here. So again, I've just put some nail polish over those as well. So other than this, the bottom board not being quite as clean, you know, on the underside as the top side, I'm happy with it for now. I think it's as good as I'm going to get it. So you can see the chemical treatment literally did next to nothing there. It's just made it go black. I suspect if I scrubbed around that with some sandpaper now, it might come up a bit cleaner. You know, the black stuff on the surface might come off and it might be metal underneath. But nevertheless, I thought, let's have a go with electrolysis. So I've got a large plastic tub here, as you can see. It's absolutely huge. And it's just the right dimensions for the board here. So I'm going to submerge this in water. We'll add some sodium carbonate, which I understand acts as an electrolyte. So on one side here, we'll have a steel rod, which I've got. It was only a few pounds from eBay. And on the other side, we will connect the to the chassis here. So electricity will flow through the circuit that way. And I think, in theory, it should remove the rust. It's just important which way you get around the positive and the negative, you know, your anode and your cathode, in relation to the water, connection to the water, if you like, with the probe, and the chassis itself, the objects you're trying to de-rust. Once we've done that, I think what I'm going to do is, I've got some zinc as well, and we can use that same process. Instead of using a steel rod there, we can use the zinc rod, and we can zinc plate it. Now zinc's kind of like a dull metal actually, so it won't be very shiny. Nickel might be a better candidate for something like this, but I just want it to be rust proof, and zinc is is rust proof effectively. So yeah, I've got no idea how well this is going to work, if at all. This area here might now be a problem, because this area is kind of just rust, and that's not. The other thing is, it's the type of rust, and it's what's actually happened here. Has it been another kind of chemical reaction other than rust? I'm not sure. What I do know is you want to be super careful using electrolysis on certain metals. Stainless steel, for example, if you anything stainless steel, if you use stainless steel for the cathode or whatever it is, the rod that goes in there, you get chromium. And chromium can cause you all sorts of health problems. I mean, significant, serious health problems. If you're going to try something like this yourself, don't necessarily follow the advice and stuff I'm giving in this video. Go away and research it very, very, very thoroughly, and be 100% sure on the metals that you're using and the chemicals you're using. Make sure you've not got any potential for chromium in there at all. And the other thing I'll point out with this is, as part of the electrolysis here, once this process starts, you get a byproduct. I forgot what it is. I think as the water breaks down, you got H2O2 molecules, and you produce hydrogen and oxygen. Now, hydrogen obviously is highly flammable. So if you were to do this in a very tight area, it could be subject to explosions and things. You could build up a load of hydrogen, come in, switch the light on or something, bang. So yeah, again, you've been warned. I'll probably do this, possibly do this outside. I'll run some wires through the window or something. Just leave this sat outside at the back. I'll stick the lid just loosely on so that air can actually get out and the wires can get in. And I'll probably do it that way. Actually, it's the safest way, rather than having a hydrogen explosion in the house. So strictly speaking, I should clean up that area first, but because we don't know what kind of chemical reaction I'm going to get going on there. Hopefully nothing too significant, but as you can see, just filling this up, we'll just let this get to the point where it's submerged. Perhaps give it a half an inch or an inch of on top, and then I'll start adding the other components and things. So I'll add the sodium carbonate now. I'm going to be trying super careful with this. I don't want to get it all over the place. It can be an irritant. You should really wear rubber gloves for handling any of the stuff when you're dealing with something like this. So we'll just liberally spread some of this in there. This is going to actually form the electrolyte. You get better conduction with electricity. Some people add salt. I think you could do the same thing with other things as well. So here's my steel rod. This is just going to sit, like I say, in one side of the tank here, if you can call it a tank. Might need to support it with something. The other thing I'm going to need to do here is move this around various places, and move the connection on this around various places, because you're going to get uneven effect going on here. It could be super hard to do this way. You might need a much bigger tank and much bigger probes and higher voltage and stuff for something this large. This is the sort of thing that the process here I've seen demonstrated on screws and nuts and maybe small tools and things. I haven't seen anybody do anything this big before, actually. So I've got the negative connected up to the chassis there, and over here, I don't know, you can just about see, we've got a bit of bubbling going on there on the positive side. Not a lot, but it just shows that the reaction has actually started. So this will take quite a period of time now for this to complete. I'm going to finish stirring up some of the bicarb here, because you can see, you know, it's not very well distributed. We may add some more. I can switch the power supply I'm using here into current mode. I'll show you in a sec, and we can just see how much current this is pulling, you know, how much current's been drawn through here at the moment. And adding salts and things, or adding some more sodium carbonate, could actually speed up the process. You can see some stuff coming off there already. Yeah, you can just about see the bench power supply there, so I've got it set to about 10 volts ish. So switching over to amps, we've got, I don't know, about 0.3 or 0.4 of an amp, I think. So yeah, I just don't know, like I say, how successful this is going to be. So just a quick update, it's been going overnight. You can see how much rust has accumulated on the piece of steel there. I've cleaned that off a few times actually. You can just about see, if I just zoom out a little bit, see this piece of sandpaper, you get loads of rust actually transferred onto the steel there. But if you look at the metal here, can you see there's just like little bits of the metal showing through before there was none? And it's the same all the way across this actually. The chemical mark that was sort of all over the other side, that seems to have gone, and you can actually see more metal actually there. It's going to take a considerable amount of time. I think the reason it's going to take so long is because this is so badly rusted. I mean, it really is. I can't imagine much worse examples. You know, the layer of rust that's on there, super thick. But you can see, you know, the current that's been drawn now is very little there, less than I don't know, 50 milliamps I think, or around 100 actually. Just looking at this, yeah, 0.5's in the middle there, so probably around 100 milliamps ish. I'm looking at a strange angle here, so I can't really see straight exactly what current's been displayed there. If I switch on to voltage, you can see the needle shoot completely the other way. I found that the higher voltage you get, obviously a higher current and stuff. I did add some more sodium carbonate in there to speed up the process a little bit. One funny thing, and I didn't capture it, when I added it in, it landed, you know, the powder went in and it landed on various places, and it crystallized. It crystallized because of the electrolysis system going on, you know, the process. And I had to then use a plastic tool to chip all the crystallized sodium crystals, I'm presuming that's what it was, off, you know, sodium carbonate. And then it eventually started to disintegrate and stuff. But yeah, that was a funny mistake. It was all like big clumps of solid white stuff stuck on there. I thought, oh my god. Yeah, it's a lot worse than it was yesterday. This is a lot more solid material deposit on this, but it does tend to come off. Can you see that? Just move the thing around and it comes off. It's awful. But this is why the current drops over a period of time. Well, that and the state of the water, you know, the state of the electrolyte as well is going to be a factor. So at some point I'll perhaps have to empty this and redo it. But I'll get most of it off like this and then go over it with sandpaper to get this down to, you know, almost steel again, if you like, and remove as much rust as I can. Put it back in and I'll show you the current will shoot up again. Yeah, and you can see as you do this with sandpaper, it makes a crunching noise as all the bits of rust start to chip off. I mean, it's a bit wet as well, so it's a mucky mess this, but yeah, this is the easiest way I found of doing this. I mean, strictly speaking, just dry it off, and then maybe get the Dremel or something, you know, if you've got a grinder, just run it across some sort of grinder or something, just to chip all this off and clean it up, because you can see it's got like a thickness, you know, there's a thickness there. We've got a thickness of rust. I'm getting it all over my hands here. I'm going to have to go and wash my hands in a minute. And I should be wearing rubber gloves, really. You know, you don't want to risk getting contamination on you, because like I said, there could be other metal deposits in here, like chromium and stuff. You don't want to risk that. If I just switch it on, just watch the current. Look, going up half an amp, just over half an amp. So yeah, we've got a much faster reaction going on there. And as you can see, you get these bubbles coming off here. So yeah, we've got a clear reaction going on there now. And in fact, look at the current. It's gone right up. We're really super high. We're sort of bordering on an amp, and actually the power supply's cut off is limited around there, I think. So that's why it keeps going, it keeps bobbing that way like that. It's like, no, I can't do that. I can't do that. I'll probably just reduce the voltage a little bit at this stage, like that. And then as it drops, as the current drops, I'll increase the voltage back up to 30 volts again. So as you can see, I emptied the water here, and I used a paper towel and just wiped over it, and you can see it's pulled tons and tons and tons of rust off now, but it's kind of black. Now what I'm not sure about is whether that's something to do with the carbon from the sodium carbonate, because I have read that sometimes when you do this with your rust removal, it ends up being black afterwards. But there's still a lot of rust there in places, you know. And obviously the labels have survived, strangely enough. I thought those would have come straight off. So I'm going to have another go at this now. We'll leave it for another 24 hours and just see where that leaves me. So there we go, it's going again, but there's barely 100 milliamps at the moment. It's surprising actually that after emptying it and filling it back up again and putting more sodium carbonate in there, we've got very little in the way of current. So this is 24 hours later. You can see I did rotate the whole thing around to give the opposite side, you know, more of a blast. So you can still see it's looking a bit reddy here. This is the area that we had the chemical treatment on originally. But most of it has come off actually. There's still lots and lots of rust coming off there. I did clean the rod there about an hour ago actually. Can you see that? It was really, really thick with corrosion from, you know, being left overnight. But you know, an hour later you can see it's gained quite a lot of rust again already. It's quite time consuming to do this actually. It's I would say on something this large, it's not perhaps as easy as some people make out. Although I'll point out what I said earlier, that originally my plan was to cut that bar into at least two and have two rods in different positions, both connected to the is that the positive? Yeah, the positive. If you had one in each corner of the tank here, that way, and maybe connected the ground into the middle, then you're going to get perhaps more of a reaction, you know, because you've got 4 times the amount of anodes there. Is it anode? Yeah, it is, yeah, the cathodes are negative. But nevertheless, it's working okay. Maybe it could have been faster if I'd had, you know, 4 of those in there instead of 1. So that's been about 3 days. We've still got a lot of rust in there, despite the fact I thought it was almost done, but I think it is now. I think that's as done as it's going to get. You know, there's not going to get much more rust off there. It looks a bit rusty up here, but that's just like particles have just settled on the top. If I just wipe it, you've just got a combination of the little metal flakes and like a black surface. And I think the black is because the steel is mild steel. It contains a lot of carbon, I think, or some carbon. And I think when the carbon sticks to the surface there, you get that black appearance, but that just wipes off quite easily. You know, I managed to sand it or something just lightly, but it's going to be much more manageable than it would have been if I started trying to just sand off the rust with a sander and stuff. So it's taken all the hard work out of it, I think. The other thing is, if I just show you the current on the power supply. Yeah, hopefully you can just about see that. It's almost on the 0 mark, it's right down there. And I found that as the rust has been removed, you get less and less and less current. You know, presumably when the point where there's hardly any rust on there at all, it will be quite low. But also it's because the anode has got you know, rust build up on it, that reduces your current as well over time. But nevertheless, I think I'm going to just clean it up now. You know, take it out, rinse it off, wipe it down, and start to work on it. And I just want to show you, if I just wipe this, just watch what happens. Can you see? Yeah, that's carbon. That's the carbon from the steel. So, you know, even just with a paper towel, I can wipe some of that off there. You start to get a more smooth surface there as you get the carbon off. But I've got a sander, I could sand this now, but it's not going to take much work to do that. I've also ordered a couple of different metal wire brushes actually. Just to give it a bit of a brush, but you know, all of the bits around the edges and things that were rusty, they have all come off. So I'm not going to go with wire wool, but the other thing you can do, and I think this seems to be the recommended approach, is to soak something like this in an acid or an alkaline. An acid is preferable, I think. But yeah, all the carbon's coming off that. I don't know if you can see that. That top rung there, look at that. It's really nice. So after I had a quick go at the middle bits here, you can see overnight it's just started to develop a bit of rust again. It's amazing actually how quick rust starts. So I need to just finish this off now, and then I'm going to make sure there's no rust on it, and I'm going to zinc coat it. Do wear a mask like this, because the particles that come off, you're going to be breathing in, you know, bits of carbon and bits of iron or steel or whatever it's made from. So yeah, do wear a mask. So before I treat this, I'm just wiping this down actually with some of the white vinegar. I'll go over it a few times. Can you see? We get like a brown, you know, it's like almost like a thin layer of rust. It's probably because it's been sat around for a few days waiting for the other components and things, you know, the other chemicals and things here. For the electrolyte, instead of using the sodium carbonate, what you use this time around is Epsom salts, which is magnesium sulfate. And you may think that's not important, you could just use any kind of salt really, and that probably would work, but you're going to get some imperfections and you're going to get a different kind of reaction going on if you just use like sodium, you know, salt, just plain salt. So I've added the Epsom salts and a bit of sugar as well, not a lot actually, and that should help you know, form the electrolyte there to get this working. But I'm seeing quite a good current actually, 3/4 of an amp at the moment. I mean, some of the crystals you can see down here are not dissolved in properly from the Epsom salts, but as the process gets going, I'm sure that'll dissolve a little bit further. I can start to see a difference already actually. We've got some like really nice light grey bits appearing over here and in various other places as well. It's only been going a few minutes. Yeah, can you see the bubbles forming there on the piece of zinc? So yeah, I'm just going to need to watch this for a period of time now I think, and then just leave it. Maybe leave it for 24 hours or so. Well, it's not going as well as expected actually. There's been a number of shifts and turns in direction. What I've had to do at the moment, as you can see, I've got, well, you perhaps can't see, I've got like an anode down there and a cathode down there, just to try and get a load of zinc into the water. But it is inevitably, you know, obviously the chassis being in there, the metal being in there, is passing some of the current. So you've got bubbles coming off the end of it there, there's bubbles coming off the side of it here. At one point I had the anode down here actually, and it kind of plated that side there. So I would suggest that the best way to do this actually is just to have the zinc in there to start with on the anode and cathode, and dissolve a load of it if you can, you know, into the solution to start with. Leave it going for like 24 hours or something until your zinc's dissolved. Then use some fresh plate for the one over there, which, let me think about this. Yeah, in terms of plating, that one's the positive. The negative goes to the thing you want to plate. The other big problem with this is the tank, the size of the tank versus what I'm trying to achieve here. Ideally what you need is a really deep tank and have the board sort of lengthways in there, if that makes sense, and shift its orientation, you know, from and have it in the middle, you know, not right next to the plate there. So this is the problem, and you can sort of see, can you see down here where it started to plate? I had this over there a minute ago and it plated just the top there and the side. So this is not going to plate the whole thing, but I can continuously move this around, shift around, just try and get a distribution there. But as I say, at the moment, we've kind of the metal part itself is not in the direct circuit there, although it is, you know, it's passing some of the current through the water there. It's not got anything clipped onto it. So the idea is, if I can dissolve as much of that in there, then I'll clip it back on and I'll alternate the position of the anode around the place, maybe even over the top. Here, I'll find, you know, I'll stick something across the top and support it flat over the surface of the water and keep moving that around. But this is going to take an awful lot of time. I'm not sure it was worth it. The removal of the rust with the electrolysis was, but using this same sort of process here to plate it, it's not as practical with the shape of the tank I've got here. So you can see what I've been doing here. The zinc is almost gone. You know, that was one of those full-size plates. I don't know if I've got any left. I think, yeah, I should have two somewhere at least. But it's consumed 2 whole plates of zinc so far. Now my power supply is super warm, just because of the current draw. It's been on for all week actually, this. But as you can see, you know, as I've gone along, it looks quite dark over there. It just kind of go dark coloured on its own. This light patch here, after an hour or two, will just fade out on its own. Now the vinegar's probably something to do with that, but yeah, I'm just trying to evenly coat. You know, I've done each little bit. I need to do this bit up here and down here next. The sides have already had quite a good go, because originally I started off with this hanging on one side or the other, and I just rotated it around. So, you know, this is not going to look all shiny and silver and new and all that sort of stuff when it's done. But after I've gone over it with the metal wool there, you know, steel wool, just gently, it should look okay. It should look pretty much like they tend to look, you know, when they've come out of a cabinet, which is, you know, steel with a coating of zinc. Even if it's uneven and bodgy all over the place, it doesn't matter. It's just the rust that we're trying to remove here. Someone could always sand it down and spray it if they wanted to. As you can see, not bad actually. It's come out pretty well. You can see this is the area that was really black before, and can you see it's gone a sort of funny colour now? This is the zinc. It is zinc plated. Maybe I should have sanded it further down first. You know, we might have had some carbon deposits there that the zinc has adhered to. But nevertheless, it's hard to get it off. You can see there was more zinc applied on this side here, but it's smooth. The whole thing is totally smooth. You can see the light, it kind of looks a little bit yellowish in places, but for the most part it looks okay. If you think back to how much corrosion was on this, it was horrendous. You can see there's a lot of zinc here actually. This corner had an awful lot of it, so yeah, I could smooth that down with some sandpaper. It's quite soft compared to steel, but nevertheless, all the corrosion has gone. It was originally lacking all of the screws, so I've got 5 brand new screws there, as you can see. So yeah, that's looking sweet. Now I think what we'll do next is program up a unibars for this board. It's going to go to Riot Retro Gaming. Now I've got to give a special thanks to Ak, who's one of my patrons and a subscriber, but also to Razula. Now I think Ak did some sort of deal with Razula. Razula is, if you're not aware, the author of the unibars. And the unibars, it's a replacement BIOS for the Neo Geo. But it gives you lots of extra features. It gives you cheats for games. You can switch easily between AES mode and MVS mode, so you can get the benefits of having a limited credits playthrough on a game. And in fact, that's what I'm going to recommend to Ant actually, that uses the unibars here, to change it into AES mode before he plays any games, and just use limited credits, because otherwise it becomes a pointless experience, the MVS. Just, you can just stick credits in, credit after credit after credit, complete the game, every single playthrough, and it feels a little bit pointless, as a pointless thing. That's just my personal view. I think it's better to put it into AES mode and have the 3, 4 or 5 credits that you're limited to, and try and beat the game on that amount of credits. But yeah, special thanks to Ak, because he, as I say, I cut myself off. He did a deal with Razula, and Razula gave him a load of unibars licenses, I think like 20 or so or something. So Ak kindly was going to donate 5 of those to me, and I said, well, to be honest, I won't be able to use 5, but I tell you what, I could certainly use 2. I could use 1 for myself and 1 for Riot Retro Gaming. So he kindly agreed and said, yeah, no problems at all, speak to Raz, and Raz provided me a couple of custom unibars. So they're not standard, they've got a custom message on the front screen, you'll see in a minute when we program this up, and a custom serial number. You can pick the serial number, and that's a really nice feature. I don't know whether you have to pay extra for that normally, or whether it's just a VIP thing that Raz just offers to friends and family. I've got no idea, but nevertheless, we'll program this up. And whilst those chips are raising, I thought I want to test this programmer to make sure it is working, because as you saw, there were a number of things I had to do to fix this, and I'm not convinced it's reading correctly. So I've put a mask ROM in here. This is from a 1FZ or something. If we choose to read that, you can see it's progressing away there. And once that's finished, we can have a look at the buffer here to see what it's actually read. and just see if there's anything in there that looks, you know, plain text regards to it being a Neo Geo BIOS. I'm guessing the ordering of the characters is going to be mixed up there. So what I mean by that is, you know, the endian, it reads the, you know, the first byte and the second byte and swaps them around. You know, the read the opposite way around. You'll see what I mean if you go into the buffer here. So you won't see sort of like, I don't know, SNK or Neo Geo. Yeah, you can sort of see what I'm saying here. You're going to have the words system there. So you've got, you see where the Y is there, you've got SYSTEM, system. There it goes, NE-EOGO dot, I think. Do you understand what I'm trying to say there? It's like you read the byte to the right, then the one to its left, then you move to the second, you know, two to the right, and then the one to the left. That's the way it's ordered in the ROM there. In terms of when we're viewing it on a PC like this, you know, on 68,000, it will read them the opposite way around. So that chip has finished erasing, so I'll do a blank check. Device is empty. Yeah, so I've loaded the Unibars there. You can see it says Universe BIOS 40 by Razula. The interesting thing is, the bytes are not swapped here. That's got me a little bit worried, actually. He might have done that, so it's easy to tell. Yeah, I suspect he's done that, so it's easy to tell when you're actually loading it up. Because I think Anthony over at ROG has tried this in his emulator, and it worked okay. So anyway, we'll have a go. So all we've got to do is do action program and just wait for that now to get to 100%. Yeah, that's in. So let's now power that up and give it a try. It's not working. I just get a black screen here. So a very long story short, I've ended up sticking Unibars 3.2. Now this is the free version. Technically speaking, you're not supposed to use this on an actual physical board, but Riot Retro Gaming do have a license, certainly for version 4. Effectively, I've just, you know, gone back a few versions. I don't have a newer version of this. I think I've got 3.3 for mine, but they've got my serial number on. So yeah, this is the only version I feel comfortable running on this board just for the moment. It works perfectly with 3.2. With version 4, I might do another video on it when I come to work out what's wrong with version 4. And just the same on my other 4 slot. You saw we just got a black screen. You can get past that. If you put the cartboard on there and put a game in slot 1, then it will spring to life. But as soon as you power cycle it, you know, after you, because you've not got a battery on here, this is the thing. So as soon as it's been powered off for a few minutes, you switch it back on. If you've not got a card again, it just like boot loops. You get, it's not really a watchdog because it's not frequent enough for a watchdog. But every 3 or 4 seconds, you get like a thing on the screen, just like a flicker, as if it's doing a boot loop, and it just goes round and round and round. If you're lucky, you can get it to come up with a crosshatch. But more often than not it won't, and the only way to get around that is to put a game in slot 1, and I just don't like that. It's something not quite right with it. So yeah, it's going with 3.2 for the moment. So here's the final result, and as I kind of expected, it was never going to be absolutely perfect, but I think you'll agree, it looks pretty much how you would expect to find one of these in the wild at the moment. And in fact, it's better than the one I've got. It's better than my original 4 slot. If you look at the one I've previously shown on my channel, it was coated with something slightly different, I think. It's kind of got like a bronze sort of look to the top of mine, but it's really patchy, and all the labels are worn off. Now you can see what I did with these labels is I took photos of the old ones before I did any work to the shell, and then reproduced the artwork here myself and printed these off. And it took a bit of work to get the scale just right. I had to, you know, when it came to print, I just increased or decreased the scale of the actual image. Printed to sticky, you know, labels, and then just cut them out and stuck them on. I also then stuck sellotape over the labels as well, so these are kind of waterproof. You could wipe this and these would be okay. So you know, you can see I did the 4 for the slots there, the A and B here, and the thing at the back here. So this is going to go to Anthony over at Riot Retro Gaming, and what I told him is what I would do personally. I'd remove the labels I've stuck on there. I can give him the artwork for those if he wants to reprint them. Push comes to shove, I can even reprint them for him and send him some labels he can stick back on himself if he wants to do that. But what I would do next, and I just haven't got the energy, I've posted on Twitter, I am suffering from neurological problems at the moment. I'm getting problems with nerves of various places around my body, and it's causing me no end of trouble. I might sound like I'm okay on these videos, but the pain I am in from the minute I wake up to the minute I go to bed is just unbelievable just at the moment. And one thing that seemed to coincide, all these problems started about a week or two after I did the electrolysis on this shell. So whilst I think that, I'm sure the shell's okay to handle and stuff, the point I would make is be super careful when you're doing electrolysis. Make sure you're in a proper well ventilated room. Make sure you wear breathing apparatus, breathing mask or something like I had on when you're sanding down the shell here, because you're going to get particles. I think I was sanding it down when there was carbon on there, but you're getting bits of metal in there, and if you breathe that in, that could cause you some problems. But it's crossed my mind a number of times over the last 6 or 7 or 8 weeks while I've been suffering with these neurological problems, wondering if it was something to do with some contamination I got when I did this work. So yeah, you've been warned. I don't think it is. I think it's coincidence. I think it's just coincidence. The other thing is, wear rubber gloves. There were a couple of points where I put my hands into the water, to remove things. There was zinc in there at the time and rust the first time, but you never know. In that rusty water, we could have had chromium, because they do chrome, or chromate, I think they call it, some of these shells. So whilst there's nothing on there now, because it's just been stripped back to bare steel, there could have been some chromium in there. That's a possibility. So yeah, I don't know. Anyway, hopefully I'll get a bit better soon. So what I've recommended to Anthony is, what I would do with this is remove the labels, sand it down, wipe it down first, because it's, I've wiped this with a coating of WD-40 to stop it rusting. But the thing is, if you leave this for a month in a damp condition, it'll start rusting again, even with the zinc coating, because the zinc has not covered everything. You can see a little bit of it there. Can you see that? Just a tiny little bit of a browny sort of colour. So yeah, I suspect if this is not treated and painted or something, it'll just rust again. It's super easy for steel to rust like that, but it perhaps wouldn't have done if I'd have managed to zinc plate the whole thing properly, so you got an even zinc coating all over the whole thing. But considering the condition it was in when it arrived, I think it's come on leaps and bounds actually, and I've got no doubt that Anthony will be able to do a really nice spray job. He's pretty dab hand at spraying things. He sprayed some bumpers on his Scirocco recently, so I suspect it will be something interesting for him to do anyway, and customise it, maybe stick some nice Neo Geo decals or something on there. There we go, so 121 in slot 1. I think because it does a reboot, that's why it was going through the different slots again. That's the reason why you should always have it in slot 1, a multi-card game like this. But as you can see, that's working fine. I've done the mods to this board, so Anthony shouldn't need to modify the 121. It's my second copy. I had a spare. Sweet. Yeah, so in the end it's turned out really well. The other thing I'll be including is, Anthony asked for some components actually for a Spectrum joules per coulomb composite fix mod. So there's an inductor there and a couple of caps, so I'll include that as well. I do hope you found the video interesting. Please like, share and subscribe. I'll catch you in the next video.